So the concept of active-active and active-passive is very important considering the exam. So easiest way to remember this is to imagine it in a way that in active-active, you have a replica of your application running in another location or region always. So the whole setup is available to you. That is why it's active on one location and active on another location. And you can route traffic to any one of these regions that you have at the same time. So when it comes to active passive, you should remember that one location has an active setup running, but you have another location or region where you are running your scaled down version or minimized version of your application or even your actual setup as well, but they are not active at the particular moment. So only one is active at a particular given point of time. So that is why it is active passive. Now let's come back to the diagram here. So here, as we already discussed, backup and restore takes hours of restore. So it takes hours to restore. So that is why it's just for low priority use cases or less critical workloads. And you provision your workload post the disaster that has occurred. And this is the lowest cost disaster recovery. And as we move forward, we come to Pilot Lite. So as I already told you that in Pilot Lite, most core or critical components and services of your application are replicated in another region, like your important data and storage replicas, and other services are turned off and used only during the testing time. So here you have live data, but considering some of the services are kept idle. So it might cost you more than backup and restore, but it will surely take less time for your recovery process. Then we come to the next active passive disaster recovery strategy or setup, that is warm standby. So here your services on another location or region are always running, but it's a scaled down version of your actual setup. So this is very good for business critical applications, and when you have a disaster, you can scale up your resources. And obviously it will cost you more than the previous two setups that we have, but it is reasonable with recovery time, and the recovery time is in minutes. So it's a very good option as well. So next is the best disaster recovery strategy, but it costs a lot more than any of these other disaster recovery strategies, but you get zero downtime and zero data loss in multi-site active-active. So try create a balance between recovery time and cost as per your business requirement. And that's what I would suggest. So here as well, when it comes to RPO, that is the maximum acceptable amount of time since the last data recovery point. So to remember this, imagine this scenario. Whenever you create a data set, you keep a copy of that in another location so that in case you lose the original data, you have a backup from which you can recover your lost data. So imagine someone tells you that they will keep a replica of your data every second. And in case you have a disaster, you can recover your data that was lost up to 1 second of the time when the disaster occurred. So you'll be very happy, isn't it? But when he says he will charge $500 for every replica that gets created, then you will be taken back and you might feel it's too costly, isn't it? And another person tells you you will have zero data loss, but you will have to pay $1,000 for the amount of data that is being replicated. So you might be really excited about this, but this will be beyond what you can afford or your business could afford, isn't it? In some cases. So here as well, you have to consider what your business outcome is, and based on which you have to take the decision of which disaster recovery strategy should you choose. So here we have the graph of cost and complexity versus data loss before service interruption. Remember this point very carefully. We are talking about data loss before service interruption. So having said that, we all know that with multi-site active-active, you get near zero data loss because you have near real-time data replication. So it may be around in seconds. But backup and restore is considered to be most efficient when it comes to cost, because your backups are created in the same region as their source and are also copied to another region, but it gives you the most effective protection from disasters. You might ask how? Because you have the data backed up and you can restore it into another setup, but the thing is that it'll take more time. That's the only problem. But the interesting thing for us is to see that both warm standby and Pilot Lite have similar data loss, but the cost and complexity is less for Pilot Lite compared to warm standby. And you will ask me why? That's a good question. So here both of them use near real-time data sync because both of them have live data with periodic backups. But the difference in recovery cost comes because in Pilot Lite, most of the services are turned off or are kept idle compared to warm standby, which has a scaled down version of its actual application. So I hope you got the point here. So now we reach to our step number 9, the most important one, that is disaster recovery options in the cloud. So let's talk about disaster recovery options in the cloud with a few more detail. So we have already discussed these options before, which are available to us ranging from the low cost and low complexity of making backups to more complex strategies using multiple active regions. So let's talk about them one by one. The first thing that we'll talk about is backup and restore approach. So as the name tells you, the approach in this will be to take the backup and restore it to another region along with the infrastructure that you have. So that's a very straightforward approach, isn't it? You take the backup and restore everything or the infrastructure along with that in another region. So this is your active region where you take your backups, and this is your DR region, that is your disaster recovery region. The RPO is the recovery point objective. That will depend on how frequently you take the backup, and that's where your point in time backup helps you. For that, we are using Amazon S3, which gives us the feature of S3 cross-region applications. So we are storing EBS snapshots and the DB snapshots on S3, which will be replicated across the region using CRR. And with the help of AWS backup, we can also copy our backups of our configurations across regions. And the importance of backing up configuration is that it will help you launch your infrastructure using that configuration with CloudFormation or any other IAC that you're using. And it is advised to use a different account for your disaster recovery region that you have here. So in case your account gets compromised in here, it does not get affected to your other region. But even though you use AWS backup to restore the data, it cannot be done automatically. Or the restore cannot be done automatically. So in order to do that, we have to make use of AWS APIs to automate that. When it comes to taking backup and taking restore, what we can do is we can create jobs using APIs, which can be executed periodically in time based on a trigger point. So the AWS backup sends the notification about the job once the backup is completed. So it gets notified to the user using the AWS SNS notification service. Then using the SNS, we can trigger the job by invoking Lambda function for testing, restore functionality and cleanup actions, based on which we can perform the restore operation and cleanup for the EBS block storage. So I'll repeat it once again. So what we can do is we can create jobs using APIs, which can be executed periodically in time based on a trigger event. So AWS backup here will send the notification about the job once the backup is completed. So the user will get notified along with that using that SNS notification service. And then SNS, what it will do, it will create a trigger to execute the job by invoking Lambda function for testing restore for a backup and the cleanup functionalities and actions. And based on that, we can perform the restore and cleanup of the EBS block storage. Now coming to Pilot Lite, as we have already discussed, here we have the database and storage always active, but the application servers which contain the code and configuration are turned off or kept idle. So I've highlighted important pointers here for you to keep your focus on that particular thing that is important. So the first thing that you notice here is that until a disaster occurs, we don't route traffic to the disaster recovery region, as services and resources are kept idle there or they are turned off. But having said that, you have the option to quickly provision the full scale of your production environment by switching on the resources that are currently turned off. So that's a very good thing as well. And for data replication, we can create Aurora replicas by making use of the AWS Aurora global database that gives us the feature of asynchronous cross-region replication. We already have a video on the Aurora database. Please go through that to understand more on how the replica works. For the routing, we can also make use of global accelerators, and based on the health check, it can direct traffic to the appropriate endpoint. And as we already have mentioned before, if you see the application servers are turned off here. And we can also make use of Cloud Endure for our disaster recovery as well if we wish to have our data centers or on-premise locations restored onto the cloud. So now let's come back to warm standby. So this is similar to Pilot Lite, but the main difference here is that you can see the resources and the workload that you have in your standby location are scaled down. But having said that, unlike Pilot Lite, this environment with warm standby is completely functional, but it's a scaled down version of it. So in other words, it is like less powerful than the actual environment. But don't get confused here. It's a copy of the actual environment, but just a less powerful one. And when you have a disaster, or if you want to support more users or traffic, you can also allow routing to this region by just scaling the resources that you have. Currently, if you see, the Route 53 is inactive for the production traffic, but if you want, you can also route the traffic by allowing the traffic through this. And if you want to support more number of traffic, then you can also scale it up. So on the right hand side, you can see it is mentioned minimal instances running. So we just need to scale it up to match the production environment. So I hope you understand the difference between warm standby and pilot light. So on pilot light, the services are turned off completely, but in warm standby, it is scaled down. So now we reach the most expensive disaster recovery strategy. I'm just kidding, but it's very expensive, but actually provides you zero downtime and near zero data loss. So with multi-site active-active, you can run your application in both regions simultaneously, and that is the active-active strategy. But there is one more advantage here. So as we mentioned, or as we discussed just now, with multi-site active-active, you can serve traffic on multiple regions at the same time. That's obviously an advantage. So, but having said that, you can also serve traffic from a single region. That is called hot standby, active passive, where you have an application hosted on multiple regions, but you can choose the one region that always stays active to serve the traffic. But you might have a doubt here that if you have to use hot standby, it's better to go with the warm standby. At least we'll save some money, isn't it? Yes, you are absolutely right. So if you're using active-active, go with that. Else, going to hot standby doesn't make much sense. And in active-active, you might feel, what is failover in this scenario? So yes, there is nothing called failover. It's just traffic redirection, and that's what we test when testing for disaster recovery with site-site or multi-site active-active. For replication, obviously we can make use of DynamoDB global tables, and you can route the right transaction to the closest region that you have and also use it for continuous backup.